In section 6.4, we're going to talk about the secant and cosecant graphs. So remember that cosecant is equal to 1 over sine of t. So just like we did for sine before, now we're going to take all of those sine values from negative pi to 2 pi, but then put them, do the reciprocal, and see what we get. So at negative pi, sine is 0. So 1 over 0 is undefined. At negative pi over 2, sine is negative 1. At 0, sine is 0 again, so 1 over 0. 1 over 0 is undefined. At pi over 2, sine is 1. At pi, undefined. Or I should say, cosecant is undefined. At 3 pi over 2, cosecant is negative 1. And at 2 pi, it's also undefined. So it's undefined whenever sine is equal to 0. Okay, so a couple things with sine. You can't divide by 0, so that's why we have our undefined in our table, but over here, it's undefined and it's an asymptote, okay? So those are going to be vertical asymptotes. Another thing, the reciprocal of a very small number is a very large number and vice versa, and we'll talk about that in a second. And then, obviously, this reciprocal of positive or negative 1 is the same thing. Okay, so when we are to graph these functions, the first thing I know is that I'm going to have an asymptote at all the values that I marked undefined. So I'm going to highlight them in yellow. Okay, so at pi, at 0, I'm sorry, negative pi, 0, at pi, 2 pi, and 3 pi. Now, I don't care if you use a highlighter, I don't care if you dot in the same color, but I have to see these vertical asymptotes. So, going through how to graph this, we're actually first going to start with graphing the sine function. So, the sine function crosses through the point 0, 0. So we have a point right here. Then at pi over 2, it's at 1. At pi, it's at 0. At 3 pi over 2, it's negative 1. At 2 pi, it's 0. At 5 pi, 1. And when we continue, this is what we get. And if I go back left, then at negative pi, we're also at 0. So I'm just going to sketch, and I really highly recommend in some way you do this too. So I'm going to dash it knowing that this is my sine function and it's not the actual cosecant that I'm trying to graph. And we're going to use this. At all the mins and maxes of our dotted sine graph here, we are going to create the vertices of our cosecant. So it'll make a little bit more sense when I actually graph it. So that means I'm going to have a vertice at pi over 2, or negative pi over 2, at pi over 2, at 3 pi over 2, and at 5 pi over 2. And this is how we graph it. So you can just remember a couple of these tricks and know that this is the shape and what it looks like. You know that we have vertical asymptotes that we get close to but we never touch. And it's almost like a bunch of quadratic looking functions. Note, this is not a quadratic. That is not what I'm saying. But it just has that shape for each of those parts, or each of those intervals. Okay, so how does this make sense? So remember before when I said the reciprocal of a very small number is a very large number. So if we were to look at pi over 2, for instance, the output is 1, and the reciprocal of 1 is 1. So that is why my black hashed line and my red curve share that same point, because the reciprocal of 1 is 1. Same thing with all the vertices and all the mins and maxes. However, if I took this output value right here, whatever that is, it is clearly in between 0 and 1. So that's a number smaller than 1. And if I take a reciprocal of that, then it's going to become a bigger number, which puts the output value around here, which is clearly greater than 1. So again, if we take the reciprocal of a number, and now it's negative, but it's in between 0 and negative 1, it's still going to be negative, but it's going to be a greater negative number, or a greater, or a smaller negative number, I should say, down here. So that's that concept. You can choose to do it that way, or you can just have this graph memorized. Okay, so getting rid of that, let's talk about the domain and the range. So first, the domain. Now, t, our graph here, can't be at intervals like negative pi, 0, pi, and 2 pi. And we know this because of our asymptotes, and that trend continues, so ... So how do we write this in interval notation? So at any integer n, so at any value n pi, we are going to include integers n plus 1 times pi. So that's the output value. So basically this is saying so if n is 1, for instance, so from 1 pi to 1 plus 1 pi, which is 2 pi. So, and we can see that up here, we went from 1 pi to 2 pi, but that's what it can't equal. And that's why I have parentheses. So it's pretty much saying any integer n times pi, the domain includes every number in between that value, n pi, and the next integer pi. So that's why it says n plus 1, one more. And a little bit of notation with this is we're going to state this, but we have to state when n exists as an integer, and these are the fancy math terms. It's kind of like a double Z, if you will, and Z means integer. So you pretty much just have to state that n's an integer for this to be true. Okay, so that's the tough part of this. My range here is going to go from negative infinity to negative 1, and we do hit at negative 1, but then we have a gap, so then we start back up at positive 1 and go up towards positive infinity. So for the period, where if we start at 0, it repeats itself again at 2 pi. So basically, if we start at 0 and we go until it repeats itself, that's right here. So we have a graph in the positive in between 0 and pi, and then a graph of cosecant in the negative from pi to 2 pi, and then again it goes back up after that. So that's where we start repeating, up in the positive, negative. So our period here is 2 pi. And then symmetry, it does have symmetry. It is odd symmetry, and an easy way to remember that is it's just like the sine function. Okay, so now onto our secant graph, which we know is 1 over cosine. Okay, so very similarly, at negative pi, we have a cosine value of negative 1, so we have a secant value of negative 1. At negative pi over 2, cosine is 0, so therefore secant 1 over 0 is undefined. At 0, 1, pi over 2, undefined. Pi, negative 1. 3 pi over 2 is undefined. And at pi over 2, it's also 1. Everything on the right side there is very similar to the sine function, so we're just going to go ahead and we're going to begin graphing. So, just like before, I'm going to plot the points that I'm given. So, I have a point at negative pi, negative 1, at negative pi over 2, 0, 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, 2 pi, 1, 5 pi over 2, 0, and 3 pi, negative 1. So again, I'm going to draw a dotted line just to remind myself of my cosine function here. This is what it looks like. Again, it needs to be different. I need to know that it's not part of the secant graph, because it's not, okay? It's just to help you with reference. So we're going to draw our asymptotes again. So it's undefined at negative pi over 2, at pi over 2, 3 pi over 2, and 5 pi over 2. Okay, so now that we know that the mins and maxes of our dashed black line are cosine, are also part of our vertices in the shapes of our secant graph. So this is what my secant graph looks like. So for this one, since it's shifted a little bit differently than sine, we actually begin and end on just half of it. So at negative pi and 3 pi, those are just pieces of like the full curve like you have in sine. So since we shifted, we kind of cut those in half. Okay, so domain is very similar. So our value of t can't be intervals like negative pi over 2, positive pi over 2, 3 pi over 2, and so on. So we say the domain is 2 times an integer n minus 1. And we take this and we're going to multiply it by pi over 2. So what that just did was create an odd numerator, basically, pi over 2. That's basically what it did. So that's my domain, okay? And then it goes to that same 2n minus 1 value to the next, oh, I'm sorry, 2n plus 1, because it's to the next odd numerator pi over 2 value. So to help with this, basically I'm saying, like, if you looked above here, we went from pi over 2, 1 pi over 2 to 3 pi over 2. So the next jump would be 5 pi over 2. The next one would be 7 pi over 2. So I'm pretty much saying, like, our domain is in between each of those. So negative 3 pi over 2 to 5 pi over 2, but we have parentheses because it can't be on those actual values because we have asymptotes there. It's, you know, we can't be at 5 pi over 2 or 7 pi over 2, but everything in between. So that's that notation. And again, we need to say that n, when n exists for all integers. Okay? All right, so my range is going to be the same. So we're going to have it from negative infinity. It goes all the way up to negative 1. We include negative 1, but then we have a gap in between 1 and positive, negative 1 and positive 1 to positive infinity. All right, so if we start at 0, let's see where we repeat ourselves for the period. So we have a sliver there, and right there, then we begin repeating ourselves. So again, our period is 2 pi, and just like cosine, we have even symmetry with our secant graph. So pretty much the bottom line is that dashed black lines for both the cosecant and secant graphs are of sine and cosine really help you form the inverse of that the cosecant secant functions. Okay, so let's look at some practice. So the first thing we need to do is we know that it's cosecant, but we need to identify what's happened to it. So we actually have stretched this. So it's been stretched vertically. And we know this because of the 2 in front, which tells me that my amplitude, which is affected by any stretch or compression, equals 2. Okay, so with this being said, the first thing we're going to do before we start graphing is a little hint, which is first sketch y equals 2 times sine, so the inverse of t. So first sketch that. So if I did that, then I'm going to have an amplitude at 2. And since all we did is stretch it vertically, the values on my x-axis here are going to be our normal pi over 2, pi, 3 pi over 2, and 2 pi. Because we have a period of 2 pi because that didn't change, and pi over 2 is a quarter of 2 pi. So we count by each quarter. Okay, so again, we're going to sketch our sine, or 2 times sine of t. So sine always starts at 0, 0. So we're here, 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 here. So it's going to look like this. Okay, so now what we need to do, and I might run out a little bit of room here, is that we share the vertices, right? So those are my 2 vertices. Because it says over here in the directions, sketch just 1 period. So I'm only going to have 2 parts here. All right, so before I can do those curves in the positive and negative, I'm going to draw in my vertical asymptotes. So I have a vertical asymptote at 0, at pi, and at 2 pi, which creates my almost 2 columns, if you will, and then we can curve, cut off a little bit at the top, like this. Okay, so now we're going to sketch the graph of secant of 2 pi. So we need to identify what's been done, and since we have 2 on the inside, that is a horizontal compression. And what that means is it affects our period. So our period is 2 pi over that value, b, which is 2, so it's just pi. So one cycle is going to be just a distance from 0 to pi. So again, a tip, first sketch y equals cosine of 2 pi. I'm sorry, 2t. Okay, so when I do this, my amplitude didn't change, it's 1. Now, I'm counting all the way up to pi for one period, which means I have pi over 4, pi over 2, 3 pi over 4, and then pi. So at cosine, I'm up here, pi over 4, down to 1, to 0, to 1. So this is my sketch. So after I draw in my vertical asymptotes, now those are going to be, it's never at 0 for cosine, so it's at your first interval, which is pi over 4, and then 3 pi over 4. So we have just one big column here, which means that at this vertice, I share 1, 2, 3 vertices, whereas the one we did above only was 1. And that's because we have a little sliver there, a little sliver there, and then we have a full curve down at the bottom. Okay, so the next one is to write an equation for the graph below. So a couple things. So far we have y equals a, which affects our amplitude. Now, the big thing to know is this cosecant or secant. And since it looks like our asymptote is at 0 and 2 pi, that means that since it's at 0, we know it's going to be 1 over sine, which is cosecant. And then we have to figure out what our b value is, and then that's it. So we have a and b to figure out. So what's my amplitude? Well, by looking at the graph, from this vertice to the 0, the center, we have a value of 1, and that's my amplitude. Now b, however, b equals 2 pi over your period. So what's my period? So I need to figure that out. So when does it repeat itself? Well, from negative pi all the way over to 3 pi. So that means my period equals 4 pi. So 2 pi over 4 pi equals 1/2. So my function is y equals 1 for a, so I don't need to write it, the cosecant of 1/2 t.